We're gonna get started here. We're gonna talk about transferring or transforming azimuths and bearings into each other. So we're gonna start with the easy one first. Well, I guess it's not super easy, but we're gonna start with a bearing. I guess it would help if I put the ending direction on there, right? I have the north direction, but I forgot about the end direction, so it's a northwest bearing. So we're gonna start with that. And we'll see how this goes. So I have this northwest bearing here that I'm going to turn into an azimuth. So I'm going to take and go from a north azimuth. That's what we want to figure out first, is a north azimuth. So I'm looking for a north azimuth. Okay, so I have my northwest bearing here, so I'm going to draw that line on here, and I know that it's north 21 degrees of west. So I have to come over here, like so, about 21 degrees, 24 minutes, 15 seconds west. So my line is out here like this. So this is a north 21 degrees, 24 minutes, 15 seconds west bearing. Okay. Now we're going to find the north azimuth here. So how do I find that north azimuth? So basically my meridian I'm using is the north-south meridian, right? South, east, west. So I'm wanting to find this angle right here. Okay, that's going to give me my azimuth direction of this line. So one of the important things to note is this here is 0 degrees. This is also known as 90 degrees on the azimuth scale. This is 180 degrees on my azimuth scale, and this is 270 degrees on the azimuth scale. So knowing this, we're going to be able to do the math to figure out what the azimuth is here. So I'm going to take, I know that this whole circle is 360 degrees, okay? This line is known as the 0 degree line. It is also known as the 360 degree line. So I'm going to take 360 degrees and I'm going to subtract 21 degrees, 24 minutes, 15 seconds off of that. So 21 degrees, 24 minutes, 15 seconds. Okay. Now we're going to do this longhand. I could use a calculator, but most of you may not have a calculator at hand. So it's really easy division or subtraction or addition that we're going to be doing. So 360 degrees is also known as 359 degrees, 59 minutes, 60 seconds. When we hit 60 seconds here, essentially that turns it over to 360 degrees. So this is the same as this, okay? And we're going to subtract 21 degrees, 24 minutes, 15 seconds. And this should give us our north azimuth of this line, okay? So 60 minus 15 is 45. 59 minus 24 is 35. And then 359 minus 21 is 338 degrees. Okay, so this is our north azimuth. So this line is also known as 350 or 338, 35, 45. Okay? So that is finding the north azimuth of this bearing. Now, what if we wanted to find the south azimuth of that bearing? I'm going to do this in red so as not to confuse you too much. So this is the azimuth reference to north, right? The north azimuth. And now I want to find the south azimuth. What is that south azimuth of that same bearing, this bearing here? Okay. So now we're going to go and reference it to south. Everything in red is going to be considered our south azimuth. So in this instance now, because we're using south as our meridian, south is 0 degrees, okay? And we always go clockwise. So we are trying to figure out what this azimuth is. So this would be 0 degrees. This would be 90 degrees. North now would be 180 degrees. And east would be 270 degrees because our reference meridian is from south, okay? So we're just figuring out this azimuth right here. All right, so we're going to do similar math. This time we're going to do 180 degrees, right? This is our meridian, 180 degrees, and this bearing comes off this part of the meridian. So it's 180 degrees minus the 21 degrees, 24 minutes, 15 seconds, okay? Remember, same rule applies here as we did here. So this can also be displayed as 179 degrees, 59 minutes, 60 seconds. Same thing. This rolls over and makes it 180 degrees. Minus 21 degrees, 24 minutes, 15 seconds. Okay? All right, so similarly, we can do our subtraction through. This is 45 seconds. This here is 35 minutes. And then we subtract here. We have 158 degrees, 35 minutes, 45 seconds. That is our south azimuth for the same line. So our south azimuth of this same exact line is 158, 35, 45. So that's how we just went from a bearing to a north azimuth, and then from the bearing to a south azimuth. The north azimuth, north referenced azimuth is in blue. South referenced azimuth is in red. You can sort of see as I color coded them. This is how you come upon that. Now I'm going to erase all this, and we're going to talk about how to turn this azimuth into a bearing. Okay, so let me erase this. So this math, as you go, is fairly easy to get through once you start thinking about how these directions work. And just remembering your meridian lines and how the reference comes together. So for this particular case, when we're going to take that north azimuth and turn it into a bearing. Our north-south reference line is our meridian. So This is a north azimuth. I suppose I probably should have written that up there. This is a azimuth reference to north. Okay. So I'm going to use blue this time. So our reference is from here. Now remember, this is 0 degrees with the reference in the north azimuth. This is 90 degrees. This is 180 degrees. And west is 270 degrees in a north reference azimuth system or situation. All right, so I have 162 degrees, 12 minutes, 30 seconds in my north reference azimuth. So what that's telling me is it's between 180 and 190. So I'm going to draw a line at about what I say, where I say that is coming through. So that's about here, I would say. Okay. So 162 degrees. So that's from our north. This is our azimuth angle, reference to north. It's azimuth, so I'll just say the north referenced azimuth is equal to 162 degrees, 12 minutes, 30 seconds, okay? And I want to turn that into a bearing. Well, the important thing to note is we're really worried about this angle here, right? This is what's going to tell us a bearing because we need it referenced. Bearings are referenced to connections in cardinal directions. So this quadrant here is the northeast quadrant. This is the southeast quadrant. This is the southwest quadrant. And this is the northwest quadrant. So our bearing is going to have the reference of southeast because this azimuth lands in our southeast quadrant. All right. We know that bearings are referenced from north to east, south to east, south to west, or north to west. That's how they're referenced. So what we want to do, we really need to know this angle here to understand what the bearing of this line is. So let's do that. Okay, so we know that south is 180 degrees in the sexagesimal system. So we'll take our 180 degrees, all right, which we know is also 179 degrees, 59 minutes, 60 seconds. And we're going to take and subtract that azimuth from this, okay? So the azimuth is 162 degrees, 12 minutes, 30 seconds, okay? So we're going to subtract. That's going to give us this interior angle. Straight line, the definition of a straight line, if you reference it from north, this is 180 degrees, okay? So we're going to subtract. So I have 30 minutes. I have 47 seconds. And I have 17 degrees. 17 degrees, 47 minutes, 30 seconds is this tiny little angle that we're looking at here. 17 degrees, 47 minutes, 30 seconds. Okay? Well, that also helps tell us what our angle is, or what our bearing is, because our bearing is figured out from this line here, the southerly line. So this little thing, or this little angle here, is telling us our bearing. So all we have to do to this little guy is add southeast to it. South 17 degrees, 47 minutes, 30 seconds east. That is the bearing of that line. All right, so we'll take it one further, and we're going to turn it into, this was a north azimuth. We're going to turn it into a south azimuth, okay? So we're referencing, remember, south now becomes, a south azimuth becomes 0 degrees here. This becomes 90 degrees. North becomes 180 degrees. And east now becomes 270 degrees. South becomes both 0 degrees and 360 degrees, okay? This is also known as 360 degrees. So now we're trying to find that for our south azimuth. So we're going to turn that into a south azimuth. Well, the good news is we just did a ton of math to figure out what this little angle is here. That's going to help us in discovering what this azimuth is. Okay, so our south azimuth is essentially, because we have this angle, I just have to subtract that from 360. So I'm going to take 360 degrees, which we know is 359 degrees, 59 minutes, 60 seconds. And I'm going to subtract this from it. 17 degrees, 47 minutes, 30 seconds. That's what was our answer for finding the bearing, okay? So I am going to take and subtract 17 degrees, 47 minutes, 30 seconds from it, okay? So I have 30 seconds, 12 minutes, and 2, 4. 342 degrees, 12 minutes, 30 seconds. That is the south azimuth of this line, 342, 12, 30. Okay, notice when I write these, I'm putting the degrees, minutes, and seconds in. That's important to do that. A lot of people will take and call it 342-12-30. That's okay too. I'll take that. You're signifying the difference between them with that dash in there, so you're not sandwiching together the numbers. But preference would be that you use the degrees, minutes, and seconds symbols as you do and work through problems for finding south azimuth, north azimuth, and bearings. So hopefully between the example problems I've done here, you'll be able to get through some of the conversions of south azimuth, north azimuth, and bearings. So thank you very much.